All right. The object is moving away from the origin at a constant velocity. Notice we're dealing with velocity here, or speed in a given direction. So if it's going to be constant, right, there's going to be no change in it. And no change along the time would give you a horizontal line. So the object is not moving. Realize your values here when it comes to this is the origin. This is 0, 0 at this point. So if you come down onto this graph, you know that this value is going to be 0. And here, like, is going to be -1, -2, whatever you decide. And this is going to be in the positive direction, 1, 2. All right. The object moves towards the origin at a constant velocity for 10 seconds and then stands still for 10 seconds. So we have 1, 2, 3, 4, 5, 6 of these. We need to, since we have a unit, an amount, we need to give this value. If you did 1 second, 2 seconds, 3 seconds, you wouldn't have enough space to do this because we need a total of 20 seconds. So if you set this value of time, these at 5, 10, 15, 20. All right, that should give you enough space there. 5, 10, 15, 20 seconds. So half of that time it's going to be moving towards, and then half the time it's going to be moving away. Oh, sorry. The object moves towards the origin at a constant velocity for 10 seconds, and then it will stand still for 10 seconds. All right. And that happens instantaneously, essentially. Let's say that this isn't necessarily for this one, but just in general. If I have a velocity versus time graph and I'm moving away from the detector at a constant velocity, then all of a sudden I switch direction and I start walking towards it. Well, it's immediately going to drop to the negative, and then it's going to continue along at a constant speed. So if I was staying at a constant speed towards it and a constant speed away. So this would be away, drops to the negative, and then towards. So think about that in this one as well. The object moves away from the origin at a steady speed for 10 seconds, then reverses direction and moves back towards the origin at the same speed. So the same speed. So in that case, if the velocity we're dealing with, if it's traveling at 2 meters per second when it's traveling away, it will also then need to be moving at 2 meters a second when you're going towards it. And the example I just did up there is probably pretty helpful for this one too. This one, these you can get, but just remember, this is a velocity versus time graph. So this one's telling you what? Constant speed, whatever that velocity happens to be. These other ones are not constant. They're changing. So you can see, like at this point, if I come over on the graph, I'm traveling slow, or I'm traveling slower than if I come up here and I come across on the graph. All right. So this one you can see as the speed of this individual is increasing as time increases. This one, you can take a look at that one. And then D as well. So keep in mind that this one's velocity.